All right, let's talk about 2D versus 3D deep VCarve inlays. Is it possible? Yeah, it's definitely possible. Is there considerations that you have to take into account specifically for the 3D version? Absolutely. But we'll walk through it together. At the 10.5 minute mark, I'll go through a complete deep dive into Fusion 360 on how I achieved that VCarve on that 3D surface. And then during the walkthrough, I'll have the file posted on my Patreon account where you can download it for free and you can walk through it together. So definitely check that out. It'll be in the description and in the comments. So if you want to, if you use Fusion 360, definitely check it out. There was some really good things in there that really improved the way I did my toolpath generations. Okay, so the 2D version, I had a couple issues with the tapered ball nose and how that ran and the tool that I used in Fusion to generate the tool path. I had a tolerance issue, and the file was so large and the points where it was following and the amount of steps that my controller couldn't keep up with it. So it was like, it was jaggy and it was not smooth. And so I would technically call this a fail, but at the end, the result, you really couldn't tell. But at this point, I was looking at the edges and the corners, and it didn't line up to the point where I was comfortable using a large project and inlaying something like that. So I deep dived into the toolpaths. I looked at everything. I corrected those issues and fixed the toolpaths for the 3D version. And the 3D version I had a lot of success with, which was great. So there was really good learning. And I hope when we go through the walkthrough that if you guys are having any of those issues, it will correct them. But with the tapered ball nose, I made a point of using a tapered ball nose for this specific one. And then for the 3D carve, I used just a 30 degree V-carving bit. And just to test both, see how it entered into the curly maple. And again, curly maple, this stuff is pretty brittle. I'm not machining into end grain for the inlays. So in that fact, the chance of chip out and all that stuff is pretty high. For the 2D version, I didn't have that issue. I just had that jaggedness, issue with the tool path. But I was still comfortable enough to sandwich these things together, put some glue on it, and then actually inlay these things in together just to see how tight everything was. So I got everything glued, I clamped everything, and then I gave it about 2 hours, and then I took it to my bandsaw and I cut that male topper off and did a little bit of light sanding. And when I was looking at it, I would consider that a success, even with those small little issues that I was having. Again, this is all learning, and it's experiment, and again, it was a lot of fun. I did notice that, my CNC machine, I have to do some maintenance on. My belts were starting to get loose, and I could really see that effect in the corners of this inlay. So when you really look at it, the corners, there's little divots. And even though it got filled and it's still seamless, those shouldn't be in there. But I'm very, very happy with the points and how those lined up and the very tight seam that it created. And there was really no gaps. And to me, that's a success for a first go doing the design and the CAD work, and then actually, producing that with physical material. So now the fun stuff. And I had to take a couple of considerations into account, knowing that when I did the 3D profile, specifically for the walnut, I was going to lose my Z height 0. So I had to figure out how to do that. And the easiest way is just a gauge, a cutoff piece from that original block that had its known distance, and I just used that as my Z height. My XY0, I didn't have to move throughout both the 3D version and the 2D version. That jig kept everything centered, and I cut everything square for that 3x3. Now, this was another big mistake that I had a little bit of learning on, was I was using a straight tapered 1/4 inch ball nose. And when this thing was going, it was hogging out a lot of material, and then those points just chipped right out. I mean, it was just instant. So I figured, I would fix that. I would take a tapered ball nose and I would do that 3D profile. That's a little bit less aggressive on the corners, which turned out, which was great. But I figured, I'll just test the engraving for the corners, and that was just verification that I fixed the tool path. And again, the corners were way better, but you can see the top portion of that star, that point chipped out, and then the bottom corner also did. And so that was a failed carve for that male connector. But a lot of learning. I went back into the drawing, fixed those issues, and then I reran to get the result that I wanted. But for the female version, everything was very smooth. Again, that 1/4 inch tapered ball nose, super awesome. I will leave a link into every single tool bit that I've used and the links to Amazon or the different companies that I used. Bits and Bits was a couple of them, and then Amana for the other ones. But at this point, I'm starting to get pretty excited. I'm looking at this, and the tool path is going very well. The corners are very crisp. I didn't have any chip out. I did have a little bit of chip out on the top portion of that star, and in the final product, it left a little gap because of that chip out. But again, this is just testing, just to make sure it's feasible and achievable for a larger project. And I think my next video, I'll end up doing a very large wavy flag, and I'll inlay those stars with curly maple for that project. So I'm very excited for that. At the end of the day, I was very, very comfortable with these operations and the material that I was going to use for the larger project. But same process. So I ended up experimenting on how I was going to get that topper off. And originally I was just going to go to the bandsaw and shave off and just cut that star out and then inlay it. But I figured, since I'm playing around with the machine, I'm having a little bit of fun, I figured, let's just go ahead and take the entire topper off. And that was almost a mistake because I had a lot of chip out with that 1/4 inch end mill. But when I came back in with the ball nose, it was I got lucky where it didn't eject that plug or dislodge it in any way. So got a little bit of lucky there. I think next time I'll just take it to the bandsaw and shave off as much as I can and just get a really good plug in. But end result here. So the corners are very, very well. Everything lined up extremely well. The inside edges are very crisp. I noticed a little bit of a bowing on a couple of them, and again, that's due to the belts on my machine, where I got to do a little bit of maintenance. I got to get them tight. One day I'll have a rigid machine at some point in my life, but again, for the machine that I have, these are phenomenal results. I mean, I would be comfortable on any machine doing this, and it's great. So with this, I figured, I'll put a little bit of oil on, get it cleaned up, and just really inspect everything. And what I ended up deciding to do was, for the 3D version, I wanted to see how the plug interacted with that female cutout. So I took it to the bandsaw, I cut it in half, and I wanted to see how much distance I had for that glue gap. And for the glue gap, I ended up going 0.01, but the end result, it was definitely outside that tolerance. It looked like, almost, I would say, a 1/16 of an inch gap on the bottom. So I don't know if it sat fully well, but when I inspected the corners and how the plug interacted with the 3D surface, it was pretty spot on. So again, happy with the results, and here in about, a couple seconds here, you'll see, just what I'm talking about as far as that glue gap. That glue gap is very, very important. just to get a solid fit, but you want to get it as close to the bottom as humanly possible. Again, it's a test. I'll probably adjust it. I think I had a little issue with it seating all the way down, but you can see where it interacted with that 3D surface, and everything is very, very tight, very seamless, and very, very, very happy with that result. Okay. So we're going to transition to Fusion 360, and we'll go through all the design process, some considerations, and then we'll get into that tool path generation. All right, so since we have Fusion 360 up, we'll do a complete walkthrough on some of the challenges here, and we'll identify some problems with, V-carving and then cutting in the 3D surface. We'll replicate it so we can visualize it. Hopefully you downloaded the file from Patreon. You can follow along. When you open the file, you'll see that I have the 2D version, both for the male and female, and then the 3D version for the male and female. The bodies are in here, and then I also have the tool path generations that you can actually manipulate, play with, and then actually make on your machine. So let's replicate the problem of defining the star. So if I look from the top portion down, and let me bring the sketch of the star in, you can see that the star, the overall dimensions of the star, everything is uniform. And it overlays, and when it's cut into this 3D surface, everything is maintained. So the 3D profile comes in, and the star is 100% dimensional, and it looks like a star. What ends up happening is people will V-carve downwards, and when they do that, the V-carve comes down, and it intersects lower points to higher peaks or whatever that surface is, and what it'll end up doing is deforming. So let's go ahead and we'll visualize that really quick. So let's hide these bodies. Let's go ahead and we'll just create a new sketch, and we'll use the rectangle center, and we'll center it into the center point. And all my material that I used was 3x3, and then the overall thickness was 0.75, so we'll extrude up to 0.75. We'll hit OK on that, and then what we'll do is we'll bring the star back in, the star outline drawing in the sketches. We can bring the browser tree back up. Let's go ahead, and what we'll do is we'll extrude this down, and we'll go 0.4, a negative, and then we'll go a negative. Let's do 15 degrees. So that'll give me a 15 degree chamfer for my 30 degree V bit to come in and cut all of this out. I'm going to hit OK on that. And now what I'll do is I'm going to create the plug. I'm going to come back out 0.4, and I'm going to put a positive 15 degree chamfer, and I'm going to create a new body. So that's essentially my plug into this base. So this is technically that 2D flat version of what I did for the 2D. But so inside the file, I'm going to hide all this. I have a mesh, and this is just a 3D profile, and we're going to use this to cut these two bodies that we just made. So let's go ahead and we'll do the split body, and then I'm going to select the body and the star, and then I'm going to use the splitting tool. I'm going to select that. I'm going to select that mesh. I'm going to extend it just to make sure I hit all the points. Now I'm going to hit OK. From here, I'm going to go ahead and I'm going to remove these bodies. So we'll remove those, and there is technically my inlay. And let's put some appearance on it. We'll put walnut, and then we'll use maple for the main star. So I'm going to hide this mesh because it's kind of intersecting. It's still on top. It's visible. Once we unhide that, we can see our actual inlay. So from the top view, you can see that the star isn't dimensional anymore. I've lost material, and how that 15 degrees came into each one of these points along this edge. And you can really see it when you pull up the sketch and you look from the top down, that it's definitely not the original sketch that we wanted, the original star that we wanted. If you times that by 50 on a wavy flag, I mean, it is very, very noticeable, and it's frustrating, especially for the builder, to try to overcome that. So how do we overcome that? Let's go ahead and let's go back in time. I'm gonna go to my history, and let's go ahead and we're just gonna remove all the stuff that we did. I'm gonna delete all of it. Yeah. Oh, let me make sure I actually hit my shift key. And we'll delete those. So we're back to when we originally extruded that new body. And now what we're going to do is I'm just going to go ahead and I'm going to come back in. I'm going to cut this star back out. But instead of putting an angle on it, I'm just going to go 90 degrees down, and I'm going to maintain that 0.4 distance for that cut. I'm going to hit OK on that. I'm going to hide this sketch, and I'm going to go ahead and extrude this back up to 0.4. We'll join it. But I want to make sure I select new body. I'm going to hit OK on that. Now what I'm going to do is I'm going to come back and I'm going to split this body again. So I'm going to hit split body, and I'm going to use the body to split. I'm going to make sure the star is selected also. And then I'm going to use the splitting tool. I'm going to select this mesh. I'm going to extend it. I'm going to cut again that profile. Now it created those additional two bodies, one for the star and one for the top portion. I'm going to clear those out, and then we'll just remove those. So there's my inlay that I want. So now what we can do is let's pull our sketch back up, and you can see that because we went down at a 90-degree angle straight down, it maintained the overall dimensions of the star in relation to this surface. The challenge part now is how do we put a chamfer on this, and then also the plug. And let's concentrate on the plug first. So let's go ahead, and to do this, we'll use, let's go ahead and use the draft function. Now, this is kind of an underdeveloped function in Fusion. I think anyways, that's just my personal opinion. There's some problems with this tool. It really comes down to when, if you have two faces that are intersecting at some point, if you go down far enough and they intersect, it's going to air out. So this distance is safe for me to do this operation. So we'll just walk through it. If you get errors, the easiest way is to change the overall thickness of this. So you can use the press and pull, and you can pull this down or upwards and then get to a distance to allow this tool to work. Anyways, so for the type, we're going to use parting line, and then there's three functions here. You have the face, the parting tool, and the pull direction. We'll start with the face first. So go ahead and select faces. And then what we're going to do is all the faces that we want to angle at a specific degree, we're going to select. So all the star faces, we got all those selected. Now the parting tool is the edge of the surface that you want to constrain. And when you constrain it, it's because of this setting here, fixed parting line. You don't want this edge to move, so make sure that is clicked. And then once you ensure that that's actually defaulted there, you can go ahead and hit the select tool for the parting tool, and then we'll go ahead and select all of these edges. And you got to do it in sequence. You can't bounce around. They all have to intersect. Once you get all of your edges selected, we're going to now select the pull direction, and then we're just going to go to this bottom face, and we're going to select that. Now what we can do is we can dictate the angle of the chamfer that we want. And for this case, we want 15 degrees. When we hit OK on this, it will chamfer all of those edges constrained to this profile along that edge of that star. So there, if I run my VCarve, it will follow this edge and it will chamfer all of that. So very, very powerful tool. There's a couple more things that we got to do to get the female and the male plug back together. So let's go ahead and we're going to hide that plug. And the original drawings that we made when we first started this, I'm just going to go ahead and I'm going to remove it. I'm not going to mess with it. Let's just go ahead and remove. And then let's go ahead and we'll recreate. Oop, hit the wrong plane. Let's do that again. Let's go ahead and we'll do center rectangle. We'll go in here 3 by 3. We'll hit OK. I'm going to hide the star outline. We don't need that. Let's go ahead and we'll add that thickness back on of 0.75. We'll hit OK on that. Now what we'll do is I'm going to split body again. The body is split. The splitting tool is that profile that we have, that 3D profile mesh. We'll make sure that's clicked. We'll extend it. Now what we'll do, since I have my reverse face and the bottom face, I can bring back my star and we're going to go ahead and cut this into this bottom. So from the combine tool, we'll select the base, the tool body that we want to cut from, which would be the star. And then we're going to go ahead and we're going to cut. And then we're going to keep that tool. So that body will stay after this operation is completed. So there is our inlay. So let's add some material on it so we can visualize it. And let's go ahead and pull this star outline sketch. And it is 100% dimensional from the original design. And it flows with the overall profile of that 3D surface. Let's go ahead and unhide that sketch. We have a little bit more work to do. Let's go ahead and let's do some section analysis, and we'll just see how that plug interacts with that plug, the base. So let's go ahead and we'll just bring it in, and you can see it definitely intersects. It maintains that 15 degree angle, and then I have a flat base here. Now with VCarve inlays, you got to leave a glue gap, and you know, it's user preference. I don't know. I don't have a lot of history with VCarve, so I couldn't tell you exactly what the exact dimensions you need for the glue gap. I went ahead and just defaulted it at 0.01. If you have a different methodology or a different experience, definitely leave that in the comments. Let me know. If it's like a 0.01 or 0.001 or whatever the case is, yeah, just let me know. I'm going to go ahead and hit cancel on that. Let's go ahead and we'll leave that glue gap. So I'm going to hide the main base. And what I'm going to do is I'm going to use the press pull feature. I'm going to select the bottom face. So I'm going to go up my 0.01. I'm going to hit OK on that. Now that essentially created the glue gap that I needed. Still maintain the 15 degree chamfer that I needed. Now let's go ahead and we'll join this plug with this base. Now, essentially we're good to go ahead and join this, but we still have to move this above the surface to make sure everything still fits correctly. So let's not join it yet. Let's go ahead and we're going to go to our front view, and I'm only going to select the material, outside material. I'm going to move that 0.01 upwards. I'm going to hit OK on that. Now what I'm going to do is I'm going to hide that body that we just manipulated. I'm going to bring back my plug. And now what I'm going to do is I'm going to use the press pull feature, and I'm going to go up 0.01. It still maintains the profile, and it just extends everything up. I'm going to hit OK on that. And then I'm going to bring back my other body. And now I have extended this plug to meet up with this surface. So let's go ahead and combine those. So we'll do our target body, our tool body. We'll make sure we're joining. And then we don't have to keep the tool anymore. We're good to go. So now I have the profile that I need to cut for the male body. And it intersects the bottom portion of what I'm trying to achieve for the overall inlay plug when it comes together. Leaves that gap of distance, and I still maintain that 0.01 glue gap, and we can verify that by the section analysis. So my plug is still connected. I still have my glue gap, and then I have a barrier or a distance, a tolerance, so I don't crash in when I sandwich everything together. Okay, let's hit cancel on that. Let's go ahead and let's put some appearance on it and make it where we can distinguish both of them. Now what we need to do is prepare this for our cam operation. So let's go ahead on the top portions. I'm just going to go ahead and I'm going to flip this 180 degrees. I'm going to bring this over, separate it. We can bring it down. Doesn't need to be perfect. And there we go. There is my modeled deep inlay VCarve on that 3D surface that maintains, and this is very important, it maintains the distance of that star, the overall dimensions of it. Okay, so that's where we are with this file. That's how we modeled that, both for the 2D and the 3D version. Note that I used a tapered ball nose that had a very specific radius along the tip of that. So it's not a direct V-carve. It's not a direct point. There's a radius to that ball nose, and you have to account for that. So what I did is, let me bring this back over. I put that radius in, and then when I extruded it down and put the chamfer in, it maintained it. So that 1/64th chamfer, or not chamfer, radius is along all the edges, and it matches my male insert. This ensures that I have a complete fixed at a degree seamless merger between the male and the female bodies. Okay, so now let's go ahead and we'll just go through the manufacturer portion. You'll have to deep dive for those that got into the file. But essentially, I did very specific tooling operations. I put offsets in for each. There's a lot here. I combined a lot of these for each one. But so each one has a clearing operation. And then I used the 3D pencil tool that's located here under 3D pencil. And I just want to highlight the fact, and this was the issue that I was having, where it was jaggedy and my machine was trying to catch up. And it was because my tolerances were off. And the default tolerances that are in Fusion 360 are this dimension here. So 0.0004. My machine can't get to that tolerance. My controller can't it's trying to catch up because there's so much steps and the program of the G code that it was trying to catch up to it, and it was sputtering. To fix that issue, I went in and I changed this to 0.004. And I did that the same for the smoothing, where it eliminated these excess points and arcs and all this other stuff if it was able to. And there's a really good description of it. But that's essentially how I fixed all my issues with my controller not keeping up with the G code that it had. So, but one of the reasons, the main reason too, that I used the pencil tool is Fusion does not like the tapered ball nose for the, for the engrave tool. And I don't know, I've tried modifying the tool to work within these parameters, and it hasn't yet. So if I wanted to use a 30 degree V bit that's at a point, that's considered an engraving bit, I would just go and use the engrave tool. But because I used the tapered ball nose bit, I ended up having to use the pencil tool and then program it to cut these parameters. So that was one of the main reasons. And then there was a follow-on operation, again, just a simple 2D pocket to clear up any of the issues that it had inside where it couldn't machine it for that outline that we did. So some other big highlights too. I ended up putting an offset. Well, let's go into the 3D version. I did these in 2 passes. So there were 2 separate pencil tools for the VCarve that I used because I didn't want chip out. And so I took a little bit of material, and then the next one, the same operation, I took that offset off, and I'll show you the offset that I used. The offset, let me select this one. It's stock to leave, and it's the radial stock. So radial stock is this edge, only the edge. The axial stock is the surface here. So it touched the bottom of this, but it came 0.02 away from this edge. And because this is at an angle, it skimmed the wall here, and it didn't take all the material out. And then the second pass came in and it did the same thing. So a little bit more control. And then I did another 2D pocket to clear out the insides. And then I did the same thing for the male version of this. So again, download the file, play around with it, change settings. If something goes crazy and it errors out or something doesn't work, send me an email. Leave me a comment. I'll address all of it. I can help as much as I can. I can try to make this thing work for what you're trying to make it work for. But again, it takes some time to understand these tool paths, and you just got to go through the settings. You got to familiarize yourself with it and just play around with it. It is fun. And then, if you have material, get in the shop and start cutting it out and play around with it. So these cuts did not take long at all. And then, but yeah, that's the main focus here. And I got a couple other operations that I'm going to try to do. I'm going to try to do fine text and see if I can get that to work under this methodology of, trying to do it on a curved surface. And then we can just go from there. So with that, hey, I really appreciate you guys watching the video. If you hung in there, I really do appreciate it. It means a lot. And then, yeah, just be on the lookout for the next video. If you haven't subscribed yet, definitely do turn those notifications on. And yeah, cheers. And I appreciate you guys. All right. Have a good night. And I'll see you on the next video. Cheers.